Cisco ACI whiteboard sessions and tutorials. And we're gonna start by introducing software-defined networking, or SDN. You will appreciate more and will have a solid understanding of Cisco ACI if we start from the very basics. For those who are new to this channel, welcome. I am your host, name is Dean Armada, and I'm the Cloud and Data Center. Rock Talk! And on this channel, we talk about tech careers and certifications, trivia tutorials in cybersecurity, trivia tutorials in cloud and data center, and my journey as an IT instructor. So feel free to check out the rest of the channel and consider subscribing. So, what is SDN, or software-defined networking? Well, many people, once they hear about SDN, what they will think of is the abstraction or a separation of the control plane and the data plane. So, separation of control plane and data plane. But SDN is more than that. And take note, the separation of control plane and data plane has been around for many years or decades already. If you think about the old 6500, okay, this is a chassis-based switch, the control plane is already separated. It's residing on a component called the supervisor engine. Okay, now SDN, like what I mentioned, is more than the abstraction of control plane and data plane. It can do many things as well, okay, such as centralize of management. Okay, central management. What else? It can also do programmability and automation. Programmability and automation. What else? It can also do integration to application, because the old networking doesn't have that capability. So integration or easy integration to software or applications. Okay, what else? SDN was originally open source. Okay, open source. Okay, and something that I would like to highlight, before this is a bit laughable, but now not so much anymore. So SDN was built to lessen the complexity of the network. Now maybe you're thinking, and maybe you agreed with the others, how can it be less complex when we need to understand many new technologies? We need to understand and read many books, many concepts or new concepts and theories. And of course, we need to do more labs. And some of the labs and configuration, this is something new for us. We haven't done this since we started networking, basically. Now, SDN, a lot of people think that it's complex, okay? But I would say in the beginning, or once you started SDN, yes, it's a little difficult, but the goal is to make things easier, okay? To make things easier, especially if you have a large data center network environment. Okay, so let's begin with data center or SDN network components. So originally, SDN comprises of spine and leaf switches, and maybe you're thinking, spine and leaf switches are already very common, okay? Yes, but these are all started during the early days of software-defined networking. And not only that, the switches that they use, let me add here spine 1, spine 2, leaf 1, leaf 2, and leaf 3. All right. Now, what I would like also to highlight, I'm going to connect all these switches, all right? Now, what I would like to highlight are these spine and leaf switches in the old SDN design. These are what we call the white box switches. So let me just add here, white box switches. Maybe you're thinking, what is a white box switches? Well, white box switches are cheaper than the traditional data center switches. So these are cheap. And the reason why it's cheap, because it's a dumb terminal. What do you mean dumb terminal? It's dumb because there is no management plane, and control plane. Okay, what it does is it only receive and transmit packet. Now, let me move this here because we need more space. There you go, and I'm gonna move this there. So, this SDN, or this network infrastructure, connects also to our servers. Okay, so I'm gonna add server 1, server 2, and server 3. Now, in a data center environment, obviously, bare metal servers are very rare, especially nowadays. What I'm gonna do next is I'm gonna add a virtual machines, or it can also be a containerized environment. Okay, so I will add one more. There you go. And there you go. All right, so this is one part of our infrastructure. Now, in an SDN environment, there is another component that is very, very important. This is what we call the SDN controller. Okay. Now, we mentioned that in the leaf and spine, which is the white box switches, what it does is it receives and transmit. Okay, it's cheap. It's a dumb terminal because it doesn't have management plane and control plane. Now, if you guess what's the role of an SDN controller, you got it right. This is where the control plane is residing. And the SDN controller, this is an operating system, okay? Linux specifically, or any open source OS. This holds also the policy, statistics, most of the configuration, and so forth, okay? Now, the SDN controller communicates to the leaf switches. In this case, leaf 1, leaf 2, and leaf 3. And the leaf 2, 3, since they are connected to the spine switches and the compute/servers, they will share all of this information so that the SDN controller will discover the other component. Again, these are the spines and the compute/servers. Now, maybe you're thinking, SDN controller, is this just a Linux? How can we enable, or how can we activate its capability as an SDN controller? Okay, well, there are many, I should say, tools or application for a Linux server or an open source to be an SDN controller. Okay, SDN controller will work if you install some of these SDN controller projects. These are Nox, POX, what else? Open Daylight is one of the widely implemented as well. Open Daylight. And if you're familiar with the game Street Fighter, Hadouken, Ryu, okay, there's also a Ryu SDN controller. So these are the most common SDN controller applications or tools. Now, SDN controllers communicates with the switches, specifically to the leaf switches, using a protocol. Okay, and back before the vendor SDN solutions such as Cisco ACI or Arista Cloud Vision or VMware NSX, the more popular is what we called OpenFlow. Now, OpenFlow, by its name, it's open source, it's free. I don't want to say it's easy to use, but OpenFlow, this is the language that used by the SDN controller and the switches. In this case, the leaves and the spine as well, okay, which are the white box switches. Now, OpenFlow, this is where we implement, and this is where it runs the routing processes. It's also secured. It uses TLS communicating to the switches. And this is where we will also configure the policies such as ACLs, QoS, network address translations, layer 2, layer 3 security, etc. Now, maybe you're thinking, how can we configure OpenFlow? Take note, OpenFlow is the protocol, the language between the SDN controller and the switches. Now, the configuration is done with another component, or I should say another tool. Okay, the tool is called flow tables. Why flow tables? Think about it. In Linux, the policy where we create rules of multiple denies and permit statements is called IP tables. Am I right? So let's add it here. Let me change. Okay. So in Linux, we call it IP tables. Now, in Cisco and other network devices, we call it ACL. But this is open source. This is Linux based. So what we're going to do is we're going to just change IP tables to flow table, since this is an open flow protocol, okay, an open flow project. Now, there's also one more component that we need to configure aside from flow table. This is what we call the Open vSwitch. Now, the Open vSwitch may also run on other platforms, okay, and appliances. But Open vSwitch is the DVS, or distributed virtual switches, that runs in our compute/servers. So this is DVS, and this is where we also configure our virtual switch, okay, where we can assign IP addresses, MAC addresses, routing, etc. So all of these are in a virtual environment. Now, since we talk about DVS, or distributed virtual switches, I would also like to add the Open vSwitch here. So OVS, Open vSwitch, this connects to our VMs or containers. Now, take note, SDN is not only about the physical switches, the physical devices. It can also control and push policies down to the virtual network layer. Okay, so again, SDN controller push and controls the policy and configuration to the physical switches and down to the virtual switches as well. Now, let's go and discuss more about SDN controller. So SDN controller SDN controller has two APIs. Okay, we have the northbound APIs. These are the northbound APIs, and these are the southbound APIs. Now, what's the difference? Well, the northbound APIs, this is where you create or you customize how you configure our SDN controller. Okay, again, this can be Knoxbox, Open Daylight Ryu, and this can be configured via a custom CLI. Okay, this can be an iOS-like CLI, or just like a Cisco, not Cisco, but a Linux-like commands. And you can also customize it using GUI, maybe a graphical user interface that is related or looks like what you have in your enterprise environment. Okay, and again, you can also integrate the configuration to your existing software application that automates and communicates to other devices, servers as well, or other software applications. And take note also, these are API based. Okay, when I say API based, you can easily create automation, okay, using Python, Java, and many others. There are many available programming languages in our SDN controllers through the use of network-based API, and that is the northbound API. The southbound APIs, this is where we push the configuration to our switches, to our leaf and spine. Okay, so switch 1, switch 2, and switch 3. Okay, take note, the SDN controller pushes the policy and the configuration to the switches. Switches are dumb. Without the controller, they don't know what they will do. Now, what I'm gonna do next is we're just going to create a simple policy using the flow table that we introduced. Okay, but before that, what I'm gonna do is I will add another topology. Okay, we have the switch 1, very basic, very simple, switch 1, switch 2, and let's say this is the POP or the internet. There. And I will also add two networks. Okay, two networks. One network is 192.168.10/24, and the other network is 192.168.20.0/24. This will be E1, this will be E2. Now, like what I mentioned earlier, we have flow tables, right? So the first flow table is called flow table 0. This is the first policy that will be checked. It's not flow table 1, it's not flow table 2, but flow table 0. Okay, and the other flow table, it can be any name. Okay, it can be flow table 1, 2, 3, it doesn't matter. So what I'm going to do is I will just add the other flow tables. So flow table 1 and flow table 2 here. There. Now, what I will add is just a very basic rules. The first rule will be I'm gonna permit this network. So as soon as the switches receive traffic from the source network, let's say 192.168.10.0/24, okay, it will be permitted. Okay. Now, since this is software defined, the policy are more versatile, okay, and has more features. Now, we will not only permit the traffic from 192.168.10.0, but we will also instruct the flow table to proceed with a specific flow table, which is flow table 1. Okay, and it can also be other flow table. It can be flow table 2, 3, 4, 5, etc. And this is what we're gonna do in the other rule, or our next rule, which is 192.168.20.0/24. So this is the second network. We will also permit it, okay, but maybe we will instruct this traffic to proceed with other flow table 6, 5, 7, and so forth. And lastly, we're gonna deny any other traffic. Okay, now for the flow table 1, what will happen here is we're gonna create a rule. If the destination is a public IP address, okay, if the destination is a public IP address, we're gonna permit it. But not just permit, we will also instruct it to send it out to this interface. So it should be switch 1 E1. So any traffic towards the public network will be sent out to this interface. Not only that, we will also tell proceed to FT2, okay, the flow table 2. Now the flow table 2, this is very familiar to you. What we're gonna do is we're gonna specify what IP addresses will be translated from the 192.168 network, 192.168.10.0 network. Okay, this will be translated to, let's say, 100.10.10.10. Now, if the source is coming from the 192.168.20.0 network, we will translate the source to 100.20.20.20. So this is just a basic policy of a software-defined networking using OpenFlow and flow table configuration / policy. Now, let's review. FT0, we permit and we deny a specific source. This looks like what? Well, if you are saying, if you're guessing ACL, you were right. Okay, it's like an ACL. How about flow table 1? Well, here we're telling the switch, this device, to send out the traffic or forward out to the interface E1. This is like a PBR, right? Or policy-based routing. How about the flow table number 2? Well, we are changing the source IP address to 100.10.10.10 and 100.20.20.20. So this is like what? You're correct. This is like a network address translation policy. It changes the source IP address as it forwards it out, destined to the internet. Just a little trivia before we go. Software-defined networking, or SDN, started when Google shared their data center infrastructure. They all used white box switches, custom-built server/compute systems, and it's all software-defined.